Injection molding machine has three main parts: the injection unit, the mold, and the clamp. Plastic pellets in the hopper feed into the barrel of the injection unit. Inside the barrel, a screw transports the pellets forward. Heater bands wrapped around the barrel warm up the plastic pellets. As the pellets are moved forward by the screw, they gradually melt and are entirely molten by the time they reach the front of the barrel. Once enough molten plastic is in front of the screw, it rams forward like the plunger of a syringe. In a matter of seconds, the screw injects the molten plastic into the empty part of the mold called the cavity image. The plastic solidifies in under a minute. The mold opens and the part is ejected. The mold then closes and the process repeats. Plastic pellets, which are a few millimeters in diameter. They can be mixed with small amounts of pigment called colorant, or with up to 15% recycled material, then fed into the injection molding machine. Injection molding machines used only external heating of the barrel to melt the plastic before a plunger injected the molten material. But because plastic conducts heat poorly, the temperature was uneven in the barrel. Either the middle was too cool and not fully melted, or the outer regions were too hot and degraded the plastic. Reciprocating screw, often regarded as the most important contribution that revolutionized the plastics industry in the 20th century. In the earlier plunger-style machines, plastic filled completely the cylindrical barrel. But as I showed you, the plastic was not at a uniform temperature. First, in modern units, the plastic fills only the space around the shaft of the screw. This eliminates the cooler central region, leaving a thinner, evenly heated layer of plastic. It has flights that wrap around the shaft. As the screw rotates, the flights transport the raw material forward through the barrel. The flights also serve to mix the plastic. The screw action agitates the melting pellets within the flights to create a uniform mixture. The shaft's diameter increases along the screw so that the distance between the wall and the shaft decreases. The flights then squeeze out air as they move the plastic forward, and they shear the pellets and press them against the barrel's wall. This shearing creates friction and so heats the plastic throughout. Plastic flows past the front of the screw through indentations or flutes. When there's enough plastic to fill the mold at the front of the screw, it rams forward like a plunger, injecting the plastic into the mold. The plastic cannot flow backwards because when the screw pushes forward, a check ring is shoved against a thrust ring to block the backwards movement of the molten plastic. This forces the plastic into the mold. Initially, the cavity image is filled with air. As the molten plastic is injected, it forces air out of the mold, which escapes through vents. These vents are channels ground into the landing surface of the mold. They're very shallow, between 5 and 40 microns deep. The plastic, which has the consistency of warm honey, is too viscous to flow through the narrow vents. Typically water flows through channels inside the mold just beneath the surface of the interior. After the injected part solidifies, the mold opens. So at first the mold slowly opens several millimeters to allow air to rush in and break the vacuum, and then the mold quickly opens the rest of the way so the part can be removed. When the plastic cools, it shrinks and so becomes stuck tightly on the core half of the mold. Molds have built-in ejector pins that push the part off the mold. The ends of the pins sit flush with the core half of the mold.
Now we'll use our understanding of plastic behavior to study what happens at each step in the molding process. First, the effects of heating the plastic in the barrel. As plastic enters the injection barrel through the feed throat, it is carried forward by the feed section of the screw, where it is warmed to the point where it will start to flow. The transition section of the screw continues this heating until all of the pellets of plastic are molten. The metering section of the screw finishes the melting process by mixing the plastic to produce a uniform temperature and mix of additives. As this takes place, the injection screw is pushed back in the barrel as it accumulates the next shot of material ahead of it. This means that barrel temperature zones do not physically match the location of the zones of the screw.